Hello everyone. In the previous video of Java tutorial series, access modifiers, we saw there are two types of modifiers in Java, access modifiers and non-access modifiers. In this video, we are going to look at the non-access modifiers in Java. The modifiers in Java are generally keywords that are added to definitions to change meanings. What are non-access modifiers in Java? The non-access modifiers in Java does not affect the access level or visibility of classes, methods, variables, and constructors. They are added, change meaning, and serve a different purpose. They indicate characteristics of classes and its members, the JVM. The non-access modifiers in Java are abstract, final, native, static, synchronized, transient, volatile, and strictfp. Abstract modifier. From the word itself, we can understand that these are not complete implementation. Abstract keyword indicates partially implemented or no implementation. Classes and methods can be declared as abstract. Variables and constructors cannot be declared as abstract. Java does not support abstract variables or constructors. First, abstract classes. An abstract class can never be instantiated, meaning you cannot create an object for abstract classes. Any class declared as abstract must be extended by another class. The sole purpose is for the class to be extended. Any subclass needs to be either implement all the methods of the abstract class or the subclass itself abstract class. The abstract keyword cannot be used with the static, final, or private keywords because they prevent overriding. And we need to override methods in the case of an abstract class. Abstract methods. An abstract method is a method declared without any implementation. The method's body is provided by the subclass. Abstract method declaration ends with a semicolon. Any class that extends an abstract class must implement all the abstract methods of the superclass, unless the subclass itself an abstract class. Abstract method can be declared only on abstract classes. This means if a class has an abstract method, the class should be declared as abstract. We will learn about abstract modifiers in little more detail later on OOPS concepts videos of inheritance and data abstraction. Final modifier. The final keyword indicates the value cannot be changed. The final modifier can be used in Java for classes, methods, variables, and method arguments. We cannot have a constructor as final in Java. Final classes. Any class declared as final cannot be overridden, meaning it cannot be extended. So, when we don't want the class to be inherited, final class is used. Final methods cannot be overridden by any subclasses. Final variables can be explicitly initialized only once. A variable declared final can never be reassigned. However, the data within the object can be changed. So, the state of the object can be changed but not the reference. With variables, the final modifier often is used with static to make the constant class variable. Method arguments can be declared as final. Method arguments are essentially the same as local variables. Of course, method arguments declared as final cannot be changed within the method. Native modifier. The native modifier indicates that the method is implemented in platform-dependent code. The native keyword applied to a method means that the method is implemented in a language other than Java. Using this, a Java application can call the code written in C, C++, or assembly language. In this case, a shared library or DLL is required. Native can be applied only to methods, not on classes or variables or constructors. Note, a native method's body must be a semicolon, like abstract methods, indicating that the implementation is omitted. Example. Disclaimer. The views shared in this video are only personal opinion. The video does not intend to hurt anyone's sentiment. Some of the information are gathered from various sources on the internet, which might not be 100% accurate, hence recommend discretion. There might be some terms or acronyms usage that was not explained initially. Recommend to go with the flow. They will be explained in the later part when it is ideal in the current video or subsequent videos of this tutorial series. Static modifier. The keyword static means that the entity is part of the class. Variables and method declared as static belong to the class rather than an object. The memory is allocated to static variables and methods at the time of class loading. The use of static modifier makes the program more efficient by saving memory. In previous videos, wherever we defined a constant variable with a static keyword are all examples of being loaded at the class level. Classes and constructors cannot be static. Static variables will exist independently of any instances created for the class. Only one copy of the static variable exists regardless of the number of instances of the class. Static variables are also known as class variables. Local variables cannot be declared static. Similarly, static methods will exist independently of any instances created for the class. Static methods take all the data from parameters and compute something from those parameters with no reference to variables. The class variables and methods can be accessed using the class name followed by dot and the name of the variable or method. Synchronized modifier. The synchronized keyword used to indicate that a method can be accessed by only one thread at a time. The synchronized modifier can be applied with any of the four access level modifiers. Synchronized keyword cannot be applied to classes, variables, and constructors. We will look at synchronized in details later during videos about threads in Java. Transient modifier. Understanding transient modifier in Java requires prior knowledge on serialization in Java. For now, just remember variables and method declared as transient are skipped when serializing the object containing them. The transient keyword applied to a variable of a class to indicate that the variable should not be serialized when the containing class instance is serialized. Serialization is the process of converting an object into a byte string. When we don't want to serialize the value of a variable, then we declare it as transient. A simple example would be a user class that contains username and password, where we want to skip password data during serialization. All we need to do is add a transient to the password variable. Volatile modifier. The volatile keyword indicates that the change made to variable are reflected to all other threads that are accessing the variable or thread. The value of volatile variable is always read from the main memory and not from the local thread cache, which in a way can be viewed as it helps to improve thread performance. But usage of volatile does not guarantee thread safety and concurrency issues. Though some would argue use it with the synchronization or monitors, none of them are ideal solution. I personally never prefer to use volatile modifier and avoid them at all cost. If you are working on web or enterprise application in multi-threading environment, I highly recommend to avoid this. strictfp modifier. Another modifier probably that is least used. The strictfp modifier can be applied to only classes and methods. Variables and constructors cannot be declared with strictfp. Making a class as strictfp means that any method code in the class will conform to the IEEE standard rules for floating points. Without that modifier, floating points used in the methods might behave in a platform dependent way. If you don't declare class as strictfp, you can still get strictfp behavior on a method by method basis by declaring a method as strictfp. As you can see, a class can be abstract, final, or strictfp. You can use strictfp with abstract or final, but you cannot have a class both abstract and final. Local variables can be only either final or no modifiers specified. Non-local variables can be final, static, transient, and volatile. Methods can be final, static, abstract, synchronized, strictfp, and native. The predominantly used non-access modifiers are abstract, static, final, and synchronized. Native, transient, volatile, and strictfp are not used that often. We will look at some examples to get better understanding of abstract, static, and final modifiers. First, let's look at the abstract modifier examples. In this class, we have defined the class as an abstract class, which means this need to be overridden. Here, the possible options, we can use either abstract or final or strictfp. We cannot use both abstract and final. If we use, it will show error, illegal combination of modifiers, final and abstract. In the abstract class, we have defined a protected variable to check how the child class is able to access it. Then we have a static final variable, constant variable, just to show how we can access the static variable. Then an abstract method. As you can see in this abstract method, it ends with a semicolon. There is no implementation or body for this method. Then we have a protected method and a public method. There is a commented part of code to indicate what will happen in case if we try to perform an implementation on abstract. As you can see, it shows compilation error. Abstract methods cannot have a body. So now we have defined an abstract class. For this abstract class, we must define a child that will extend this abstract class. The new class, sample abstract child, that extends sample abstract class. Here we are overriding the print sample abstract method, which is an abstract method defined in the sample abstract class. What will happen in case if we don't define this? It will show compilation error. Here I have used auto override annotation just for better readability. This is not necessary. And then another public method which will in turn call the protected method of abstract class. The reason for defining these two methods is in an abstract class we can have abstract methods and non-abstract methods. So this one is a non-abstract method with the proper definition and implementation. Here this is only declared, whereas the implementation is specified in the child class. In order to execute and check the results, creating a class, defining public static void main, within that creating a new object for sample abstract child class, and then calling one by one method. Let's execute and check the output. Next, let's take a look at the example for final modifier. We have declared this class sample final with final keyword. So this is the final class. In the final class, we have declared a final variable, and then we have a method which contains a non-final argument and a final argument. As you can see, non-final argument can be changed, but a final argument cannot be changed. We cannot assign a value to final. The method arguments declared as final cannot be reassigned. Then the final variable. Will we be able to modify the final variable? No. This example is an indication for that. So, final classes cannot be overridden. Let's create a sample child class and see if we can override it. As you can see, we get compilation error. Cannot inherit from final. In order to illustrate the final method, can we override a final method? For that purpose, we create a parent class which contains a final method. Here is a final method and here is a non-final method. In the child class, we overwrite the non-final method. We try to override the final method, it will throw error. Let's create a demo final modifier class and define void main to see the output. Create an object for sample final class and pass the arguments. Since count is a public variable, we should be able to modify. But since here we have defined it as final, we won't be able to reassign the value. Then we are creating an object for sample child class and then we are calling the print methods. We are creating another class sample object. This class is to illustrate data in a final object can be modified. So in this sample object class, we are simply having a string variable with a value object. We have declared this sample object as final, but within the sample object, we can reassign the object check. Basically, for a final object, we will be able to change the data or state. So here the output should be object state changed. Let's execute and verify the outputs. All the values are printed as expected, including the final object modified state. Finally, to explain the static modifier, we are defining a class sample static. Here we have a static variable and a non-static variable. Then of course a constant variable which is defined as static final. The static variable can be within the static method, but the non-static variable cannot be used within the static block. As you can see, non-static field cannot be referenced from a static context. But in a non-static method, we can access both the static and the non-static variables. Let's create a demo static modifier class, define void main, and then print the values. We don't need to create object for static variables or static methods. So static variables and static methods can be directly accessed simply by specifying class name dot the static method or static variable. Here we are creating a object for sample static just to see whether we are able to print both non-static and static variable from a non-static method. Let's execute and check the results. So you can see all the results are printed as expected. Let's recap with a quick 2-minute summary. The non-access modifiers in Java does not affect the access level or visibility. They are added to change meaning and indicate characteristics of classes and its members to the JVM. The non-access modifiers in Java are abstract finals, natives, static, synchronized, transient, volatile, and strictfp. Abstract modifier. Abstract keyword indicates partially implemented or no implementation. An abstract class can never be instantiated. Any class declared as abstract must be extended by another class. Any class needs either implement all the methods of the abstract class or the subclass itself another abstract class. An abstract method is a method declared without any implementation. Abstract methods can be declared only on abstract classes. Final modifier. The final keyword indicates the value cannot be changed. Any class or method declared as final cannot be overridden. Final variables can be explicitly initialized only once. A variable declared final can never be reassigned. Method arguments can be declared as final. Native modifier. The native keyword applied to a method means that the method is implemented in a language other than Java. Using this, a Java application can call code written in C, C++ or assembly language. In this case, shared code library or DLL required. Static modifier. The keyword static means that the entity is part of the class. Variables and method declared as a static belongs to the class rather than an object. Static variables and method will exist independently of any instances created for the class. Synchronized modifier. The synchronized keyword used to indicate that a method can be accessed by only one thread at a time. Transient modifier. The transient keyword applied to a variable of a class to indicate that the variable should not be serialized when the containing class instant is serialized. Volatile modifier. The volatile keyword indicates that the changes made to variables are reflected to all other threads that are accessing the variable or thread. The value of a volatile variable is always read from the main memory and not from the local thread cache. Strictfp modifier. Marking a class or method as a strictfp means code in the class or method will conform to the IEEE 754 standard rules for floating points. Class can be abstract or final or strictfp. Local variables can be either final or no modifier specified. Non-local variables can be final, static, transient, and volatile. Methods can be final, static, abstract, synchronized, strictfp, and native. After every topic, there will be a set of questions with multi-choice options which you can use to self-check your skill on the topic. These are derived by me for the topic. I will post the answer on the comment section. In case you got it wrong, no problem. Explore and identify what you missed. This exercise will help you learning the programming language efficiently. First question, state true or false. Class can be declared as abstract or final or strictfp. Second question, identify the correct statements. The options are given below. Third question, choose the wrong statement. The options are given below. Fourth question, identify invalid code snippets. The options are given below. Fifth, instant variables can be declared as Options are given below. Try out by creating classes similar to the example shown in the video for majorly used non-access modifiers. Thanks for watching this video.